In this demonstration, I will show how to create and edit Bezier curves in ENSnano. The first step is to create a plane on which we will position the points of our curve. Then, I position the point of the curve, and I select the kind of grid that I want to, with which I want to equip the curve. So in this example, I want to equip the curve with an hexagonal grid. Then I can select a point and choose the cyclic option to make a closed shape. And finally, equip the curve with DNA strand. Here I'm choosing a length of 1200 nucleotides. And this is too much for the shape because the shape is too short. I can arrange this by adjusting the size of the shape by dragging the corner like this. Once the size is approximately correct, I can now fix the problem that my curve is intersecting itself. To fix this, I can translate the grid so that the DNA strands are not in the same plane and do not intersect themselves. Here it seems that it's about correct. I can adjust so that they touch. So this is approximately the correct size. And I can adjust the length of the curve again, because due to the modification, the shape is now a bit longer. Notice also that the roll of the helices is automatically adjusted so that at the junction, the helices have a synchronized roll. I would now like to show how to add points to the curve and edit its shape. To add a point, first I select a point of the curve and then select the Add Point tool. Then I choose the position of the new point. And now, to edit the shape of the curve, I go back to the normal action mode and move the point of the curve. While I do so, I can create, for example, doing so, I can create a 5-star branch, and notice that the shape of the DNA strand is automatically recomputed. In this shape, I have now some rough edges. I can make them smoother by moving the tangent like this. By making the tangent larger, I get smoother edge. And with this kind of structure, the difference in length between the outermost and the innermost helix can be quite significant. This needs to be taken into account when doing crossover, and that's why the indices displayed in the 2D view are not the same at a given vertical. This is due to the fact that the positions are automatically computed so that when making a crossover between close nucleotide, they will always appear vertical. So for example, if I want to join the brown and the purple strand, I create a crossover that appears vertical in the 2D view, so I can adjust it to see how it evolves in the 3D. But even though the difference in indices between the two nucleotides is quite big, here it's about 70, the nucleotides are at the same vertical in the 2D view, so I can easily adjust this crossover. This synchronization works everywhere, all along the structure. So here at this position, the shift is different. It's only of about 40, but I can still make a crossover between these two strands and use the 3D view to adjust its length. So that's all for this demonstration. Thank you very much for your attention.